I've spent almost 10 years on a documentary all about the forever chemical problem, interviewing so many different incredible and brilliant people. I decided to make this series to include highlights from each of those interviews, giving their stories more life than just a few moments in a film.
I'm Jamie DeWitt. I'm an associate professor in the Department of Pharmacology and Toxicology of the Brody School of Medicine at East Carolina University. PFAS is an acronym for a class of substances known as per- and polyfluoroalkyl substances. There are about 10,000 individual chemicals in this class. They are synthetic, they are organic, and they contain fluorine. PFAS matter to a great deal of people. PFAS matter to industry because they have properties that make them very useful in a really wide variety of products and processes. They matter to us because we purchase the products that contain PFAS or for which PFAS are used. We also are concerned about PFAS because as a result of their use, they are now in the environment. And they are part of our bodies. They are part of the food that we eat. They're part of the water that we drink. They're part of the air that we breathe. These health effects include two different types of cancer, testicular and kidney cancer. These effects include thyroid disease, ulcerative colitis, effects on the immune system, effects on cholesterol, effects on liver health, effects on developing babies, and effects on reproduction. Two of the compounds that have been studied fairly extensively are known as PFOA, or perfluorooctanoic acid, and PFOS, or perfluorooctane sulfonic acid. PFOA used to be one of the major constituents in the creation of nonstick surfaces, and a trade name for one of those is Teflon. It's made by a company that produces fluorochemicals. The other, PFOS, was also a main ingredient in Scotchgard, which was also made by a major fluoro manufacturer. Both of these compounds are known as legacy compounds. They both have 8 carbons. They differ a little bit chemically, but they've been studied the most because we've known about them in the environment for the longest period of time. So immunotoxicity is fairly well established for PFOA and PFOS, the legacy PFAS about which we know the most. But the data are really still emerging on some of the newer PFAS that we're finding in the environment, things like Gen X, things like Naphthalene byproduct 2, and PFMOAA, this whole alphabet soup of PFAS. Here in my laboratory, we ask questions about what these compounds do to the immune system, and we're finding that some of them can produce similar toxicities to PFOA and PFOS. So we're finding that these new compounds might also produce negative outcomes on the immune system. So when we talk about immune suppression that's induced by some of the PFAS that we study, we're talking specifically about a response that's really similar to a response that's created when somebody gets a vaccine. So you introduce what's known as an antigen or a non-self agent, and the body makes antibodies against it. And that helps so that if that antigen it enters the body again, that the body can have a fairly rapid response. So it can keep you from getting sick if you get exposed again. And what we're finding is that this response doesn't do as well as it should in the presence of PFAS. When you get vaccinated, you get an antigen, which is a non-self agent that stimulates your immune system. And your immune system then is better able to defend itself if it encounters that antigen or that pathogen again. We ask that question about PFAS, and we find that in situations of PFAS exposure, that response is diminished. So the antibody response is not as strong as it would be compared to an organism without PFAS exposure. It seems logical that if you're exposed to a chemical that suppresses your body's ability to make antibody, and you need to make antibody to fight an infection, that the likelihood of having a more severe infection or an inadequate response against a vaccine is increased. PFAS are significant for people living in the state of North Carolina. Number one, because we have a known source of industrial PFAS contamination. So we have a facility in the state that we know has emitted PFAS into the environment. We also have military bases and airports that likely have used PFAS either in training exercises or in actual emergencies, because one of the ways PFAS are used is in aqueous film forming foams, or AFFFs. I'm an environmental toxicologist, and that means I ask questions about contaminants found in the environment and what they do to health. In the laboratory, we focus predominantly on the immune system. We also do a little bit of work with the nervous system and a little bit of work with development. It means that we ask a lot of questions about what's going on inside in the body of a living organism. And on a day-to-day basis, it could mean running something known as an enzyme-linked immunosorbent assay to a biochemical assay to ask questions about enzyme activity. It could mean doing histology under the microscope to look at how weird spleen cells look or how weird liver cells look. But it does take time. Most of our studies take at least 30 days just to get data. If we're doing a developmental study, it can take probably 3 months. And then after we collect all those data, we have to analyze them. We have to check them. We often repeat our studies so that we can verify results, so that we have reproducibility and rigor as well as reliability. And then we have to write up our results into a scientific paper that will hopefully get published in a high impact journal that we can share with other scientists as well as people in the community who are interested in the work that we're doing. But ultimately, what we try to find out is whether or not exposure leads to an adverse health outcome. And that is an undesirable effect that is a marker of a disease or something deleterious that nobody wants to have happen to them. And ultimately, we hope that our data is used by decision makers to protect environmental health. Scientists are cautious, and we want lots of data so that when we do bring that data to the public or to other scientists, we're very confident that our interpretation of the data is really reflective of what's going on. What PFAS have in common is that the vast majority are persistent. That means our exposure isn't going to go away until we eliminate them from the environment. If we study PFAS one by one, it may take generations before we understand everything that we think we need to know about PFAS so that we can make a decision based on having minute pieces of information. During that time, people will continue to get exposed because PFAS are persistent. Per and polyfluoroalkyl substances have gone by many different names. When I first learned of them, they were called PFCs or perfluorinated chemicals. Now the nomenclature is per and polyfluoroalkyl substances, or PFAS. Some people call them perfluorinated alkyl substances. But I really think a name for PFAS that has stuck with the public is forever chemicals. Now, there are some scientists who don't like the term forever chemicals because it's not a very scientific term. But what it means is that PFAS are persistent. They're not going to readily break down in the environment or in our bodies. Right now, the only way we can get rid of PFAS is by physically removing them and burning them or taking them to another place. So I think forever chemicals might not be a very scientific term, but I think forever chemicals represents the persistence of PFAS. There is probably no place in the world where we can go to avoid the impact of PFAS. They've been found in the Arctic, which is fairly remote. They've been found in the deep ocean. I don't know anybody who's vacationed in the deep ocean. They've been found in the umbilical cord blood of nearly every infant that's been tested. There's really no way at this point in our history to avoid exposure to PFAS. Most chronic diseases that we experience in the world come from exposure to environmental contaminants. So it's not opioids, it's not tobacco, it's not alcohol, it's not car accidents that are killing us. It is chronic diseases such as heart disease, diabetes, cardiovascular disease, stroke. And the major player in these diseases are environmental pollutants. As individuals, we can affect change by changing our behavior, changing what we purchase, and then hopefully that will lead to the phase out of PFAS and a change in the way that PFAS are introduced into our environment. One of the things that we've learned is that people die prematurely from chronic diseases, and that the vast majority of chronic diseases are induced by exposure to environmental contaminants. If we've been exposed to PFAS since the 1940s and the levels of chronic diseases have increased in that time period, it makes sense that PFAS are part of the environmental contributors to chronic disease. We've just started asking questions about PFAS and health. It may take some time before we fully uncover all of the diseases that are caused by PFAS exposure. But it's silly to think that they're not part of the chronic disease problem that our world is experiencing today. We all are consumers, so we have a lot of power, which means that we can purchase items that we know to be PFAS free, not only to help to reduce our exposures, but to increase the number of products on the market that aren't made with PFAS and that don't contain PFAS.